Okay, this is my new favorite integral. We have the integral from 0 to 1 of x minus 1 plus log x over x plus 1 times log x. You want to stick around because the answer is possibly the best answer I've ever seen. So the first thing we're going to do is split this integral up into two integrals. As you can see, these ln x will cancel. That's really why I did it. And the second integral is pretty trivial. I'll leave that as an exercise to the viewer, ln 2. And this here is not very trivial, and that's what we're going to deal with. We're just going to call it, say, j. Okay, so this will be j, and the goal is to find j. So how should we do that? Well, we see we have an ln x in the denominator, and we have an x in the numerator. It's usually a good idea to do Feynman's trick of differentiation under the integral sign. So we'll define an integral function of a parameter t as so, and you'll see why I'm doing this, because when we differentiate both sides, we have a d over dt here, but you can take the derivative inside and it becomes a partial derivative. And that just means we treat t as the variable and x as the constant. So that means we can take these outside, and derivative would now be x to the t log x, because that's how you differentiate an exponential. So now these will cancel out, and that's really why I did this. We wanted the ln x's to cancel, and now we don't have any natural logs anymore. We can write this 1 on 1 plus x as a series. And this is valid because x is between 0 and 1. So that's why we can do this summation. Now we just rearrange this a bit. And we have this integral, x to the k plus t. And you can evaluate this for yourself. It will be 1 on 1 plus this exponent. Nice. So this is j prime of t. We want j of t. So we integrate both sides with respect to t. And well, this integral is pretty standard. It'll just be a natural logarithm. And you can see that because it's just t plus something. And we're doing this with respect to t. So this will be the logarithm of the denominator. But we need to make sure we don't forget something. And that is the plus c, because we're integrating. And here the plus c actually matters. So we need to find that plus c, and we do that by subbing in some value into the original integral. As you see, j of 0 is nice. It's just 0. So we can apply this here, and we'll get something like this. Since j of 0 is 0, c has to be the negative of this sum here. Okay, so now we know what c is. We should probably just apply it to j of t, giving us this thing here. Well, we can combine this into one summation using log laws as well. So we have ln of t plus k plus 1 over k plus 1. Great, so now we've found j of t in some sort of form. We need to be careful, well, not careful, but we need to think, what are we actually doing here? We're trying to find j, right? And j is equal to j of 1, because if you plug in 1, you just get j. Pretty standard. So we're just going to plug in 1 here and then see what happens. So this numerator would become k plus 2, and yeah. Now, might as well just write out some of these terms and see what happens. So we have ln of 2 over 1, and minus ln of, well, these are all just going to increase by 1 every time, right? So we have 3 over 2, and then plus ln of 4 over 3, minus ln of 5 over 4, plus ln of 6 over 7, wait, no, 6 over 5. Okay, and then minus ln of 7 over 6. Nice, so we have some of these terms. Obviously, this goes on for infinity, but we can actually take the sum of logarithms as a logarithm of the product. So we have 2 on 1 times 2 on 3. That's because of this minus sign here, so I had to flip it. Then 4 on 3, and then 4 over 5, and then 6 over 5, and then 6 over 7, and dot, dot, dot. We have the logarithm of this insane product. And this is actually equal to Wallace's product, or the Wallace product. And that is exactly equal to pi over 2. I'm not kidding. Pi has appeared here when it's least expected. So we found j. And remember, I was equal to j plus ln 2. And now that we know j is equal to ln pi over 2, we see that I is equal to ln pi over 2 plus ln 2. And yeah, that is going to be ln pi minus ln 2 plus ln 2. And of course, that is equal to ln pi. So the integral from 0 to 1 of x minus 1 plus log x over x plus 1 times log x is equal to log pi. That is the coolest answer I've ever seen. Thanks for watching.